Each orbital at discrete energy level determined by quantum numbers. So this orbit, right? Maybe next orbit, this each orbit has its own energy, right? So that energy will be determined by this quantum number, right? This energy would be determined by this quantum number. So these four numbers we will use for the quantum number. Small n is principal energy level. We will say principal energy level shell, right? So the designation KLMNO, right? So if you just imagine, okay, I'll take calcium. So calcium is 2882, right? Okay. So KLMNO, what this meant by is the first level is determined by the K, right? So this is denoted as K, right? Then the next energy level, we will write it as L, okay? Then the next one, we write it as M, and then N, right? And when it is going upper, then we go for O and all, right? So this is what meant by this KLMNO. So principal energy level, right? So principal energy level. So in the calcium means first energy level, we will have 2 electrons, right? Then we will have 8, right? Second energy level, we will have 8. We will have 8, right? But that is not true, right? And only for calcium, we may have in the next one 2, but for different atoms, we have much more than that, right? So we'll see. This n principal energy level is each orbital is the principal energy. So first orbital is denoted by K, second one denoted by L, third one denoted by M, and fourth one denoted by N, right? So this is our calcium, right? Okay, so this is our primary energy level, right? And then we have L subsidiary orbitals, SPDF, right? So these subsidiary orbitals are orbitals which are further classified into this orbit. So for example, if you take this orbital, right? Right, I'm going to draw this orbital now. So this is primary, right? If I draw it in secondary, this one will have an S orbit and an P orbit, right? The subsidiary orbit, so we will call it a secondary orbit also. So they will be denoted by small s, p, d, and f, right? So only these four. For the principal orbit, we have k, l, m, n, o, p, and all. But for secondary orbit, we have only these four, right? So this s can have a maximum of 2 electrons, right? And this p, it can have maximum of 6 electrons, right? And then we have d, right? So d can have 10 electrons, and f, we can have 14 electrons, right? So this is the maximum. So each main orbit would be divided into subsidiary orbit, right? But in the first orbit, there will be only S, right? So first orbit, there will be only S. In the second orbit, right? So that is L orbit. So this is your K, right? This is your K orbit. In L orbit, that is your second orbit, we will have S and P, okay? In the third orbit, so third orbit is our M, right? So in the M, we will have S and P and D, okay? S, P, and D, right? And N orbit, we will have S, P, D, and F, okay? Right? So what I'm trying to say is, if you consider k orbit, right, the maximum is 2 electron. Why? We can have only s, right? So s mean 2 electrons, right? Totally 2 electrons. So if you see here, right, this is our first orbit. We will now have only 1 and 2 orbits, right? So this is why we write the atomic structure of calcium as. So you might have write this one, right? Calcium 2, 8, 8, and 2. So in this way you might have write, right, already. So you know this way, but now I am saying why are we writing it that way, right? Why are we writing it that way? So since the first orbit can have maximum of 2, right? So our calcium we write first as 2, right? Now we go for the next orbit, right? The second orbit. In this second orbit, I told you S and P can be there, right? So S mean 12, sorry, not 12, 2, and P mean 6, right? So here 2 and 6. So how much is 2 and 6? Totally 8, right? So that's why in this orbit, we can have maximum of 8 atoms, right? Maximum of 8 atoms, right? So similarly, when we are going in the third orbit, we can have 2, 6, and D I told you 10. So altogether we will have 10 plus 6 plus 2, 18 electrons, right? So this is the way these atomic numbers are arranged, right? Usually this SPDF is the maximum amount of electrons which can be sit in that orbit. This is our calcium, right? This is our calcium. But after calcium, we have these many elements, right? So the maximum number of electrons which can be filled is the number of the last element in this row, right? So first row maximum is 2, which means this is that 2, right? S group 2. Then that is 8, right? So that is 1, 2, 3, 4, 5, 6, 7, 8, right? So this is that 8, right? So for calcium, we stopped with 2, but in calcium, that orbit, we can have maximum of these many electrons. So this maximum number of electrons which can be admitted will be determined by this SPDF and this main orbit, right? So here you see, so this is how we will write, right? So for hydrogen 1s1, right? So in hydrogen, if you take that orbit, right? So maximum is 2 because it is in the first orbit, right? So helium 2, 1s2, right? So with these two elements, the first orbit is over. Why? Because the first orbit we can have only S, right? And in S, the maximum is 2, right? As I told you, the maximum is 2, right? So here in the first orbital, we can have maximum of 2 electrons, right? Then we go to the next orbit, right? So that is, I told you, if it is second orbit, then that is S and P, right? S and P. So in S, you know 2 electrons. In P, I told you 6 electrons. So 6 plus 2 is 8, right? So maximum in the second orbit, we can have 8 electrons. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So these are the second orbital elements. So that is from 3 to 10. So that is 8 elements in between, right? So for these 8 elements, this 2s and 2p part is the different thing, right? Because this 1s2, it is already filled orbital, right? So this 1s2 is already filled. So that will now come to all the elements which are below this, right? All the elements which are below this, this 1s2 will come. So now we are talking about the second orbit, right? So these all are coming in the second orbit. So if you take the periodic table, that will be coming like this, right? So this is our first orbit, 2 maximum. Then comes to our second orbit. That is what we are now talking about. That is 8, right? 8 electrons or 8 elements we can have. So what we are doing, we bring this 1s2, that will go for all elements. Now we are concentrating on 2, right? So this 2, right, while writing this 2 is the main orbit 2, right? There is a main orbit 2. So that is main orbit K is 1, L is 2, right? So if you are writing this as 2s1, right, this 2 belongs to the main orbit, right? And this S1, S2, P1, these all are belong to the secondary orbit, right? So secondary orbit is the orbit we have this S and P and D and all, right? So if we finish with the deal with the beryllium, then we will go for beryllium, right? So for beryllium, there are totally 4 elements because this is 1, 2, then we have beryllium, that is 4, right? Beryllium, that is 4. So while writing beryllium, we will have these 2 at the start, 1s2, that will automatically come. Then now this is the second orbit, right? So we will write that 2, right? So this 2 is to show that it is in the second orbit, right? Then S2, right? So I told you S, the maximum is 2. Then we will write this S2, right? So for beryllium, that is S2, right? So this is the beryllium 1s2 and 2s2. So now if we talk about boron, it has 5 electrons, right? 5 electrons. So this is our boron and it has 5 electrons. So it has 2 electrons. So that is the 1s2, right? Then we have 3, 4, 5, extra 3 electrons, right? So 1s2 is the first orbit. So maximum is 2, that is done. Second orbit, we can have the maximum 8, right? For until 8, we can go. So we can't write 2s3, right? Why? Because in s orbit, the maximum is 2, right? So we will write 2s2 and then we will write 2p1, right? So this 2 is to show that it is in the second orbit. And this s and p, this p is to show the secondary orbit, right? Secondary orbit. So how we will write the boron 1s2, 2s2 and 2p1, right? So in s orbit, the maximum is 2, right? So until the last element neon, we will have 2s2, but the p will be keep on increasing, right? So 2p1, 2p2, 2p3, like that, p will be keep on increasing. So in neon, if you see, this is 2s2 and 2p6, right? So here s orbit 2 electrons, p orbital 6 electrons, plus 2 is 8, right? So here we have the maximum of 8 electrons, right? Wherever we are finding s, right, the maximum would be s, I mean 2. It can be 1s or 2s or 3s. The maximum would be only 2, right? So if I write in this format, right, this 1 and this 2, right, and this 3, they are denoting the main orbit, right? So this is the main orbit. And then this S2, P2, P6, D10, these all are showing the suborbital, right? Secondary orbital. Right, so here is our main orbital and here is our suborbital. If I am taking the example of carbon, right, carbon, so in your O-level days, you have written it as carbon 6, 12, right? So this 6 is our atomic number and this 12 is our mass number. But now we are not going to deal anything with the mass number. We will be concentrating only on the atomic number now, for now, right? So how to write this one is, so if you see, that is totally 6. So now we know how to draw that one, right? So carbon, in the first orbit it has 2, right? This you have already studied. And in the next orbit it will have 4, right? So altogether 1, 2, 3, 4, 5, 6. 6 electrons we have, fine, right? So how to write this one in the elaborated format, right? So in the first orbital, it has 2 electrons. So we write it as first orbital, it will have 2 electrons, right? First orbital, 2 electrons, right? I already told you S maximum 2, E maximum 6, D maximum 10, and F maximum 14, right? So this is actually the maximum, right? So maximum means in the d orbit it can have 5, 6, 7, 8, 9, 10 is the maximum. In d orbit it can't have 11, right? So D11, it is wrong, right? It can't have D11. In a similar way, S3 OP8 is also wrong, right? S3 OP8 is also wrong because maximum in S is 2, maximum in P is 6. So if we write like P4 OS1 OD8, this is correct, right? Why correct? D8 is correct, P4 is correct, and this one is also correct because maximum it can have is S means 2, P means 6, and D means 10. So below this, any number is fine. But if it is D11, that is wrong. Then it must be D10 and F1. So it will be going in this order, right? If S is finished, then we will go for P. If P is finished, then we will go for D. If D is finished, then we will go for F, right? So now we come back to the carbon, right? In the first orbit, it has 2 electrons. So 1 is 2, that is fine. Next orbit, right? Next main orbit, it has 4 electrons. So that is second orbit. So second orbit means we will write 2, right? Second orbit means 2. And first is S, right? So we will go start with the S. How much should I write here to the S? 2, okay. Okay, why is that? So maximum number S can have is 2. So I will write 2. So if I see now 2 plus 2, I have 4 electrons. But altogether carbon has 6 electrons. So now I should go for which number? Okay, P. Why is that? Okay, so in the second orbital we have only S and P. So I will write P. That's fine, correct. And now which number should I write? Here.
2, because already 4 electrons filled, then remaining is 2.
Okay, fine, correct. Because this is our first orbit. So this is 1s2. Why? Because only 2 electrons are there. That is this 2. First orbit, so that is this 1. And in the first orbit, only S can be there. So that is this S, right? So in the second orbit, this is our 2. That is for second orbit, right? And this is S. And 2, why we are writing is maximum it can have is 2, right? So if 2 is finished, but we still have 2 electrons, so then we will go for P. Yes. In each orbit, we should start with S. Each new orbit, right? If it is first orbit, then we should start with 1s. If it is second orbit, then we should start with 2s. In the third orbit, then we should start with 3s. So once the s orbit finish only, we can go for. So when we are done with the 2s and still there are electrons, then we can go for 2p, right? So this 2 is for second orbit, and we still have 2 more electrons, right? So 2p, 2, right? So if you see totally now 2 plus 2 plus 2, that is 6, right? So carbon atomic number is 6, that we have 2 plus 2 plus 2, 6 electrons we have.
We can, why we are give the elements like this, 1s2, 1, 2s2, like that. We can directly give the numbers, no? Why we are given like this?
If you directly give the number, you can't find which is the valence electrons. So in the previous lecture, I told valence electrons the last orbital electrons now, which can move here and there. So those elements will determine the most of the properties, whether it's covalent bond or ionic bond, or it can give or it can gain. So those things will be determined by this. So if we write like this, we can find, okay, so s orbital is complete now, right? No need to deal with this. So now we have this p orbit half, which means second orbit is not filled yet, right? So in order to for these properties, we will write like this. So then we can directly see, okay, this orbital is not filled, right? So when we are talking about aluminium, if first orbital is finished, by just looking at this one, we can say, okay, first orbital part is done. So we don't have to deal anything with this first orbit. And when I see to the second orbit, 2s2, 2p6. So we know in the second orbit, only s and p should be there, and maximum should be 8. So 2 plus 6 is 8. So this is also fine. And then we move to the third orbit. There we will find, okay, only p1 and 3s2 is there. So only 3 electrons filled, and there are a lot of space for the electrons to fill. And in the third orbit only space left, right? So these minute data we can see only if we write in this format, right? So this is why we break it into this small format and write.